Howdy, y'all. I'm Professor. Hold on. That's better. Howdy, y'all. I'm Professor Parks, and I advocate for the advancement of astronomy. And I am doing yet another impromptu stream. And I'm going to take a moment to check YouTube, the tubes, to see whether or not I am actually live and so forth. Let's see. Never quite get the hang of the order of operations necessary to make sure everything is where I need it to be. Well, it says I'm live, so we'll see. But I don't think I had the settings properly in place. We'll see. Oh, maybe I did. Okay, let me mute that. Thank you, Roisin. You are grand as well. I'm going to pop this out. Yeah, whatever. Live chat. Pop out. Yay. Okay. Awesome. Howdy, Judy. Thank you for letting me know the audio is good. Because one of the reasons why I'm doing this is because I had a 3-hour conversation with Austin Whitsitt over on Earth Awakenings a couple, 3 days ago. And as it turns out, my audio on Discord sucks. No one told me. So I apologize for that in advance because I do eventually plan on posting that conversation in chunks. I don't know whether or not I'm just going to split it into, 45-minute chunks and go that way, or see whether or not it makes sense to divvy it up by a subject matter, because we did sort of go all over the place. But that's neither here nor there. Just letting you know that that's going to be coming at some point. I can't ramble too long tonight because have I recovered from the 3-hour convo? Yeah, it certainly set my sleep schedule back again. I'm now pretty much on a nocturnal schedule, although honestly I've never really had a sleep schedule because things. Anxiety sucks, but I definitely, not that I was regretting that. Regretting the conversation, because the conversation was good, and I would love to have more conversations with other folks like himself who actually have ideas about how the universe is put together, where we can flush them out and I can understand where they're coming from and point out any sort of inconsistencies with their line of thought. So I don't know. Maybe that'll happen. Who knows? But yes, thank you for asking. I am quite recovered at this point. Space and the electric universe. Well, I'm reading currently this book, The Little Book of Cosmology by Lyman Page. I honestly don't know, and I need to clean my nails. I don't know who Lyman Page is. I'm not familiar with his work, although, to be honest with you, cosmology isn't exactly my expertise. Apparently, he is a distinguished professor at a James S. McDonald Distinguished Professor of Physics at Princeton University. Okay. I recommend the Little Book series to anyone. I'm sure there are books that cover non-scientific areas, but I'm getting through this one. I've read the Little Book of Aliens by Adam Frank, which is fun. Not his best, but it was fun. And the Little Book of Exoplanets, which was also pretty good. But it was in here, and for the longest time, I should say, that I did not read what could be considered pop science, essentially books that were geared for public consumption, that were just simply talking about the state of affairs within astronomy or physics or what have you. Mainly because while I love astronomy, it's my job. And when I read, I generally want to escape from, life and my job. So I never really got in the habit of reading these sorts of books. But now that my job involves public outreach and teaching and that sort of thing, I felt that it would be good for me to do this. Primarily because, and actually this is also the reason why I started actually getting into the debunking space, watching Simon Dan, Conspiracy Cats, and so forth, is while obviously they're not going to teach me anything, they will probably remind me of certain things that I haven't thought about in a long time, but they're not going to teach me anything. From a subject matter perspective, what I'm hoping to be able to pick up are techniques on how to do public outreach, public speaking, how to frame an argument, or how to frame a particular topic so that it is consumable at a general level. So basically, learn how to not overtalk my audience, which unfortunately a lot of my colleagues do not have that ability to do. They operate almost exclusively at a certain level, and they do not have the ability, for better or for worse, to come down to someone else's level to explain to them astronomical concepts in a way that they can digest and move forward with it. Is the little book a setup for the Dummies series? I'm still on volume 1 of the Dummies series. No, this isn't for dummies per se. It's really just an overview of the subject matter. This one is remarkably little considering the subject matter, but it's straight and to the point. So it will definitely sketch our current understanding of the cosmology. But even for a little book, it's pretty little. So, but I was reading that because I've come across conversations, people on Flat Earth Discords who are, obviously they have a problem with cosmology. They have a problem with the fact that cosmology does not know a whole lot about some of the most fundamental things of the universe, such as what is the universe at the very basic level. If you read a text like that, that text is essentially going to tell you that 70% of the universe is composed of our dark energy. And also in that text, he freely admits that we have really no idea what that is. Or I should say that we have no real concrete idea, or we have no concrete explanation for it. We can see the effects, and we can quantify the effects, and we can create models that are predictive so that we can better define what the characteristics of dark energy is. However, if someone were to ask me fundamentally, what is dark matter? Is it a solid? Is it a liquid? Is it gas? What is it? I couldn't tell you, and neither can anyone else. And so science skeptics, flat earthers, they really have a problem with this. They really have a problem with cosmology because of so many different uncertainties in terms of dark matter and dark energy. And so I find myself in these conversations fairly often. When I do engage, it's usually about this sort of thing. And one of the most recent, or one of the more recent conversations that I had was with a gentleman who I've noticed that I have certain triggers. When someone questions my faith, not questions. When someone ridicules my faith, I have a hard time keeping my cool. And so I, generally speaking, will exit out of those conversations before I make the situation worse. One of the other ones is being condescended to particularly on a subject matter that I am positive I know more about than the other person. Doesn't sit well with me. I do not like, you can disagree with me. You can even call me names, but I will not let you condescend to me. And so that conversation ended fairly quickly because of this gentleman's very condescending tone. He was one of those who use a lot of big words in order to sound like he knew what he was talking about, but in fact didn't. But he asked me actually a very important, very basic question. A question that I think Austin Witz had asked me at some other point down the line, or earlier, which is, what is space-time? We talk about space-time being curved. We talk about space-time being the mechanism via which things, masses attract. It dictates the motion of masses. It dictates the motion of light. So what exactly is space-time? Well, I don't have a great answer for that. To me, it's always seemed like what you're asking for is what is a dimension? What is length? Because to me, space-time has always been simply 4 dimensions. It is the coupling of 4 dimensions: length, width, depth, and time. And the fundamental, what's revolutionary about space-time is that time is not separate. It is not a separate variable. It basically acts, or is coupled rather, to the other 3. So if you have something that can affect length, it could also affect time, such as length contraction and correspondingly time dilation. But that's not very satisfying. It wasn't satisfying to me, and it certainly wasn't satisfying to anyone else. So I've been searching for a better way of describing what space-time actually is. And I found something that I like better. At least it describes space. And how Lyman Page describes it is simply a vacuum. It is the absence of anything. It is essentially that in which all other things reside, which I think I phrased it a little differently in the conversation with Condescending Dude. But that's my best explanation for what space-time is at the moment, is simply the absence. It is the environment from which all other things reside. It is, but what is most importantly, and this is specific to the next topic that I'll ramble on about, the electric energy or electric universe, is that it is not a medium. It does not have physical properties in and upon itself, other than potentially an energy density. And actually, no, I will go back. Dark matter would be the energy density located within, would have an energy density located within space-time. It actually is theoretically what is causing the outward pressure to cause space-time causing space-time to accelerate. Now, he also does a fine job to explain why, in terms of density, why the universe is expanding, or why it is that the universe went from one regime to the next, which I might come back to. But that's essentially where I'm at in terms of the best explanation that I have for what is space-time. Space-time, again, is simply the absence of all things. It is the absence of photons. It is the absence of radiation. It is the absence of mass, of whatever variety you would, normal or dark, or however, whatever exotic thing that you have. And that absence is defined by 4 dimensions. Effectively, the only description of space-time that space-time can have is length, width, depth, time, and curvature. Because again, curvature is what dictates the motions of things. And that's basically it. Again, maybe not as still may not be satisfying, but I feel it's more satisfying to me. I still have questions with regards to what space-time is. And really one of the reasons why I'm saying this is to point out that anyone who claims that they fully understand any particular field is either lying or trying to sell you something. I certainly don't know every aspect of astronomy. Even in the areas that I am more familiar with, such as planetary formation, stellar formation, that sort of thing, I do not know a large chunk of it. And I think there's some kind of weird, I think it has a name or a law or something like that, where the more you know, the less you actually know, or the more you know, the more you realize how little you know. There are so many unanswered questions out there. Once you dive into a subject, once you really get into the literature, the actual physical mechanics of things, and also doing research of your own, you start realizing, oh shit, there are things we don't actually know that I didn't know we didn't know. The unknown unknowns, as Mr. Rumsfeld famously quoted or said. So I wanted to be honest in that regards, in that I don't have a better explanation for what space-time is, other than what I've already described. And that's okay. My inability to describe to you what something is should not dictate whether or not something is or is not true, is or is not the best description of reality. Because I hear this a lot. Whitsitt has a particular phrase which actually got quoted in another book that I was reading, the Upside Down Cosmology or something like that. The dude quotes Austin Whitsitt in it, in saying that replication is unnecessary for negation, something of that nature. What it boils down to is one does not have to have a replacement theory in order to recognize that the current theory is, or call out that the current theory is wrong. That leads me to a slight tangent. This is another thing that I got into. I don't remember, I think it might have been part of the Whitsitt conversation, is that if you have followed this channel for any length of time, then you know how I feel about logical fallacies. I don't like them. I don't think that they are they are valid, but bringing them up in a conversation to me is not useful. One, it smacks of, I'm smarter than you. I know this fancy fallacy, so blah, blah, blah. But what frustrates me is that it does not propel the conversation. It does not move the conversation forward. It does not provide information. Because if I state something and then you come back at me and say, oh, that's a straw man. One, I don't know if your definition of a straw man is actually correct, but more importantly, I don't know what specifically you have a problem with in terms of my argument. Now, we're going to get there, apparently. Howdy, UK PI. I haven't seen you in a long time. You know, when someone points out a fallacy, I have seen that typically the interlocutors or people eventually get to the problem of the argument. But they could have skipped all of that bullshit if the person, instead of saying straw man fallacy, would have said, the basis of your argument is flawed because that is not the argument from which I am coming from. And here is why. Could have skipped all that. So I, like I said, very much don't like when people throw out fallacies because it's not useful. And that's really one of my heritage. I won't claim that I am this nationality or that nationality. I'm American. I will own I'm American. My stock, as it were, my people come from two distinct locations. England, sorry, Roisin and Nimrod, when you watch this, and Germany. I very much identify with pragmatism, which I associate with German. I was with the Germans. I was raised by Midwesterners, and when it boils down to is it useful or is it not? If it's not useful, then it ain't fucking worth my time, and I'm not going to pay attention to it. If it is useful, I'm going to continue to use it, even if it has flaws. But let me back up for a second. At least they left. Yes. Well, not all of it, from my understanding. They're still there, a little corner piece of Ireland. I'm not going to pontificate on that because I'm American. What the fuck do I know about that? The troubles. Anyway, so sorry, squirrel. Where was I going with this? Pragmatism. What it's useful. I don't consider talking about fallacies useful, and so I have no patience for them. But along those lines, I see a lot of, particularly when Bev was in the conversation or was relevant, and I still don't know how to pronounce this. I don't think something like a modus tollens or whatever the fuck. If Q, then Z, if only on every other Tuesday. It's a rhetorical argument. It is a logical statement. And again, I've said this before, and I think it was taken out of context once by Lucky Haskins, is that I do not believe that science is done from a rhetorical framework. We do not use modus tollens, or we do not use a law of identity to move forward. We are driven by evidence. We have ideas. Those ideas are predictive. We collect observations. We take those observations and we compare them to predictions. If they match, great. That tells us that our idea, the thing that led to those predictions, isn't crap. If they don't match, then we know that that's crap, and we need to alter it in some way. Not for nothing, I have often found that, when people come at these arguments, they do so in a binary sort of way. Because, nuance sucks. Nuance doesn't win arguments. When someone does an experiment, or when someone does some research, I think it is very rare for those observations to fully comply with predictions or fully not. Usually there's some agreement or not with it. Also, there's the whole problem with uncertainty. How well does it agree with the predictions? Howdy, Nimrod. I just mentioned you. Hold on a second. Here we go. Agua. So it bothers me when people use these sorts of arguments in a scientific discussion. Because again, it's not how science is done. And I don't believe that it is how science should be done. Is there a logical framework underneath the scientific process? Sure. I believe Karl Popper's work has expounded on that or described that or what have you. But it is, to me, not relevant to what I'm doing. The scientific method science is very much of an apprenticeship. is that you have a mentor, you have an advisor. You learn from that advisor how research is done. You also learn how research is done from others in the department, and you also will probably have advisors or collaborators outside of that. We don't have a class on the scientific method. There is no textbook that describes to us what the scientific method is. It is simply taught from one researcher down to the next. Because there isn't a, well, maybe for biologists or what have you, but for astronomers and physicists, there really isn't a like codified way to do things. There is what is proper and what is not, and you can talk about, and maybe I'm overgeneralizing it. Maybe there is a strict prescription somewhere in there, but it's not taught in that way. And so my mind does not go in that direction. And I refuse to entertain this idea that, oh, that doesn't follow the Mons Tollin, or P doesn't equal Q, or whatever the fuck. I refuse to entertain those sorts of arguments because, again, they're not useful to me. If you are telling me that the universe is not old, then you are going to need to provide me with evidence, some numerical, quantifiable data that I can then, that does not meet the predictions of the current theory. Which brings me to another sort of topic to it. Speaking English. And that is akin to the falsification, or the replacement and falsification idea. This is also something I wholly reject. Is that, does our current understanding, and I've said this many, many times, both online and in online chats, does our current understanding of the universe have problems? Or, excuse me, have unanswered questions? Of course it does. No human theory of anything is going to be without questions. Does that mean because there are questions that you can throw the whole thing out? No. Again, it's not practical to do so. Even when a new understanding supplants the old, general relativity with respect to classical mechanics, classical mechanics has some very its very fundamental nature is contradicted by GR and SR in the sense that there is no absolute time. There is no absolute reference frame. Gravity is not a force. However, again, can we use classical mechanics in almost everything that we do? Yes. Does that, just because GR is there, does that mean that we can't use it, that it's improper to use classical mechanics? No. If it gets the job done, then you use it. And that's ultimately where it comes down to, particularly with the electric universe thing, is one of the things that I found to be most astonishing in my conversation with Witsit, and again, I'll post it at some point, is that, general relativity is a classical theory. Clive, I honestly, I think that my understanding of the word classical, term classical is, well, obviously it's flawed. I will take it upon myself to learn what that actually means. But I was trying to demonstrate the difference between SRGR and Newton's laws, that sort of thing. So forgive me if my terminology is flawed. Oop, that's not what I wanted to do. Classical means non-quantum. Okay, I thought maybe that's where you were going with this. So what would you call what would you call Newton's laws? That era of things. Because to me, I'm looking over at a bookshelf, and books that I use call it classical mechanics, um, and it seems differentiated from relativity. But again, hopefully, my point is getting across. Is that Newton believed in absolute time, um, absolute space, or an absolute reference frame. He was deterministic, and he believed that Newton was a force. Newtonian dynamics. Okay, I'll start using that in the future. Thank you. Now, where was I? Falsification or replacement. One of the things. Oh, so the claim that Austin repeated, and ultimately, I think I got him to admit to what he actually means with it, is that he kept saying that there he said that there was I can't remember his specific phrasing, but he said that there was a geocentric, non-relativistic cosmology that blew away, those are his words, that blew away the current theory. And of course, I asked him, what do you mean by that? And went around and around. I think he deflected off the answer, but effectively what it comes down to is he believes in some kind of electric universe. And more the point is that he simply just thinks this is better from a philosophical standpoint. He rejects relativity and cosmology on simply a philosophical basis. What I mean by that is he refuses to accept that the universe is old, that the universe is huge, and that it is expanding. And so anything that describes the universe in such a way has to be wrong. He does not have evidence for this. He simply asserts this. And I say he, but this is pretty commonplace among really all flat earthers. He at least attempts to put forward alternate ideas. Where it fails for me is like one of the things that he kept insisting upon, and he actually tried to get me, I think this was meant as a gotcha moment, was talking about dark matter. And I said one of the pieces, and we got on to Vera Rubin and the analysis of stellar velocities and and pretty much the advent of, or not the advent, Zicke obviously, oh shoot, I got students observing in 15 minutes. Apparently I thought I had an hour, I thought I had longer than that. So I'm going to have to actually end this in 15 minutes. Can I wrap up my point in 15 minutes? This is not helping. His claim was, or the claim, current claim, is the stars are observed to be moving faster than the amount of light we believed to be, or the amount of mass we believed to be there based on the amount of light that we detect, they're too fast. So essentially there's not enough mass to propel or curve space-time enough for things to move at the rates that we are seeing. I'm just going to default to Newtonian dynamics and call it a force because it's easier. There's not enough a gravitational force to to accelerate these stars at high enough velocity. And so the replacement comes to the electric universe. He wanted me to admit that it was possible that instead of gravitation, it was magnetism, which is funny because that was the force that Kepler attributed to the motions of the planets. He did not put forward gravity. I'm unaware. I don't think he actually knew. I don't know. Timing is weird. Um, but he put forward magnetism as the cause for why the planets go around the sun in the way that they do. And so Witsit wanted me to admit that I could simply take gravity out of the equation and stick in magnetism and things would be kosher, because to him, it basically solved the problem of missing matter. You wouldn't need any matter. And I questioned him on it. It's like, okay, well, in order for that to happen, you're going to have, at least to my basic understanding, I haven't actually sat down and analyzed this anyway, but I would imagine, at the very least, you have to have a magnetic force that is big enough to cause these accelerations. And unless something is weird with magnetism, which it very well could be, you need a substantial magnetic field, or a substantial magnetic field would be present in order for that to be the case. And it would have to be fairly coherent as well. Neither of these are observed in galaxies. Galaxies do not have substantial magnetic fields, and the magnetic fields in galaxies are god-awful. Pretty much magnetic fields anywhere in reality are just fucking god-awful. In the sense that they are chaotic, go in many different directions, and cause a lot of different phenomena. Complicated. Again, not a galaxy guy, so I like my stars individually. But I told him, hey, I don't believe the observations are there to warrant that hypothesis, that the magnetic fields need to be of a certain strength, and that we don't see that. And then he cites something basically that you can propel superfluids at very high velocity or fast velocities, high velocities, using a small magnetic field. I basically had to let that go because I don't know. I'll say, I don't know what a superfluid is. I've never worked with them. I've never dealt with them in astronomy. I'm sure I can Google it really quickly. But I'm fairly confident that no part of a galaxy can be described as a superfluid. So unless you're going to say that our understanding of the constituents of a galaxy are wrong, and say that basically there are no stars, there's no stars, there's no gases and dust, and it's all some kind of helium superfluid, then no. I would not entertain the idea of a magnetism. But again, it boiled down to, and I brought that up, like there are observational signatures that would need to be present in order to explain any particular any competing hypothesis. Same thing goes with the ether. And I got into an argument at text with Alan, and given the situation that Alan's in, I apologize for being as vehement or maybe even flippant as I was. But I asked Alan the same question that I constantly get asked by flat earthers in terms of space-time. What is it? What is ether? What is it made of? What is its how do you describe it? These sorts of things. And his description ultimately boiled down to two things, which to me don't really mesh. But again, I haven't given it serious thought. One, he claimed that the ether was charged. I asked him in what form? Protons, quarks, electrons, what form? Then he switched to that it was waveforms of one variety or another. He never really answered the question. No fault to him. Apparently there are ways to do that. There are ways to apparently he's got sources that actually describe what ether is. He just wasn't in a situation to actually give me that information, which is fair. However, our our observations right now, like for example, one of the things that I always get challenged on, or not always, I frequently get challenged on, is how do we know that the space between the Earth and the Sun is empty? More specifically, we observe spectral features that we attribute to the surface and atmosphere of the Sun. How do we not know, or how do we distinguish location? How do we determine that these are where the Sun is and not some intervening cloud of gas? Well, you can do it from you can make a logical argument or assertion in that the spectral features are consistent with a rotating ball of plasma of known dimensions. And that you have to have a very, very specific, and I don't even know if it's possible, but you would have to have a very, very specific pocket of gas traveling at a very specific velocity and thus trajectory in order to mimic that. And so that's what it is. Not logical argument. It's Occam's razor. Occam's razor, the observations, the simplest explanation is that it's a ball of gas that is heated through nuclear fusion, rather than gas clouds of helium that are intervening between the Earth and the Sun. I bring up the ether because if it is something, and they claim it is a medium, so it must be made of something in order to be a medium, then I would think that it would have some kind of observational signature to it. My naive thought is that if it's made of something, then it should have spectral features. It should give off some form of spectrum, because radiation is throughout the galaxy, throughout the solar system. It's going to be hit by photons in one form or another, and that's going to cause some kind of either an emission line spectrum or an absorption line spectrum or a continuous spectrum or something, I would think. Now, I could be very wrong. Maybe the definitions of ether as proposed by others claim that it is like dark matter, that it only interacts in a certain way and would not have certain spectral features. The question I posed to Alan, which again, under the circumstances, I guess, I grant why he wasn't able to answer this, but this is a question I don't know that gets posed often enough in this context. Flat earthers, I give Austin Whitsitt as an example, frequently rail against relativity and the current cosmology because we cannot explain dark energy to their satisfaction. We do not know what dark matter is specifically. And so because we cannot explain those things must not exist. Rather than those things may not exist. Maybe there's something else that can be used to better explain the same effects. Much like curved spacetime is a better explanation of than a particle carrying force, force between two masses carried by a graviton. And maybe there's some explanation there that we don't know, but we cannot say that the phenomenon itself doesn't exist because we don't like it. And it strikes me as hypocritical that the same folks that will rail against that dark matter because we can't explain it, dark matter isn't a thing, will then put forward ether as a replacement. And then when I ask them what ether is, they can't give me a satisfactory answer. And they will admit, some of them will actually admit that they don't know what ether is. So why is it, and this is the question I posed Alan, why is it that you reject dark matter because we don't know what it is, but you freely admit not knowing what ether is, and yet you claim that it exists? So what's good for what's good for the goose is good for the gander, in my opinion. Again, pragmatism is, why is it that two things that seem to have the same innate quality of being unknown, why is one rejected for it and why is one not? Why is one proposed? And I'll close out because for those of you who may have come in late, I actually have students that are going to be observing in about 3 minutes using our campus telescope. So I need to sign off so that I can essentially be on call. So if anything breaks or what have you. My ending point is this, I suppose. Again, this is also a subject that I've talked about in terms of worldview, is science must not have one. Science is driven by evidence, not opinion, not feeling, not vibes. So, but it strikes me that the people that I've spoken with that are driven by, or driven to put forth the electric universe, or driven to put forth the Walter Bislin model of a flat Earth, that they are doing so not from a scientific standpoint, but from an emotional one. They are putting forth these things because they just do not like, for whatever reason, the current idea, the current science. And so anything that supports that current science must be wrong in the best case. And in the worst case, it must be evil. And this is out to all you globies out there. The question that I find most interesting is why do they reject this? Now, it's an easy thing to say, oh, well, they're fundamentalist Christians, so obviously they're, batshit crazy, and leave it at that. I don't find that to be a satisfactory answer. It doesn't give me any sort of information as to the motivation, because I can then answer the question, why are they fundamentalist Christians in the first place? And again, I don't like the idea of blaming religion for having a certain mindset. What I have found is that people have certain mindsets and then gravitate to the religion that they feel can best explain that or validate those perspectives, those viewpoints. So I'm that's the question that I want to have, or that's the conversation that I want to have. That's the question that I want to have with people, particularly with Austin, and hopefully that can be our next conversation, is why is it that the current cosmology, why is it so disturbing to entertain the notion that the Bible is not taken literally? Or putting that aside, what is wrong with the notion that the universe is very old and very, very big, and that we are not in a preferential position in it? And I think YZ Sooks, I think that that's my current theory, is they say it gives them an innate sense of being special. I don't know about that, but I do think that it has something to do with significance. In that there is that the current cosmology either makes them feel insignificant or informs them that human life is insignificant. And again, and I'm basically repeating myself, is that I take the exact opposite perspective. And I would like to know why they take that perspective, because I don't see it. I don't understand when someone looks at the universe as we currently understand it and how they get a sense of being insignificant within that vastness. But I'm making a guess. I'm making a guess that that is the core of why they hold to their beliefs. But I would like to have conversations in order to understand it better, because it's more fun than actually reading academic papers on the subject. I gotta admit. Anti-establishment, like in Science That says. Yeah, I mean, there you can, and in my first live stream was actually with Alan, and this was years ago, so I don't remember it specifically, but there was a lot of anti-government thought. There was a lot of distrust in the government, serious ingrained distrust in the government, that the government was in fact actively trying to hurt people. But again, my question is, where does that come from? I mean, yes, the government has done some pretty fucked up shit. I will be the first to admit that. But overall, I see government as good for society. I see the U.S. government as a good for society, even today. Yes, I know. I don't agree with I find the current administration extremely problematic. But I think, but still, on the face of it, or as taken in total, it is still a positive, an overall positive. I don't think the government has a sense of, as an entity, I don't think government has the sense of, oh, we need to kill people, we need to keep them in the dark, we need to be deceitful. And I'd like to understand why. And yes, Clive, I definitely agree with that. And I think that's the case for all of us, really, is that in some aspects of our lives, we want simple answers. We don't want complex, we don't like nuance. We want a simple answer because we want to get on with our lives. You know, if I am horrible at analogies, but if, I want to know if something is legal or not. I don't care about any kind of extenuating circumstances. I want to know, can I do this? And if I can't, great. If I can, yes, that's what I want to know. I want a clear-cut yes or no answer. Obviously, with astronomy and physics and the understanding of the universe, I recognize that these are complex questions, and I don't want simple answers. But I think that it can be said that we all, in some aspect of our lives, definitely yearn for simple questions rather than some kind of ambiguity or some kind of nuance. And it definitely seems as if Flat Earth is wanting the simple answers in this regard. And again, I'd like to know why, because to me, again, it's the exact opposite. We're talking about, and I really need to go, to me, what is the drive to understand astronomy is the drive to understand the basic, most fundamental questions that we can ask. Where did we come from? How were we made? Where are we in terms of the grand scheme, the grand design of things? These are the questions I want to know. These are the questions I need to have answers for. And so I will not accept simple answers to that. And I don't know why anyone would. Again, maybe because it just doesn't affect their everyday lives, so they don't give a shit. But if they don't give a shit, then why are they so vehement in the rejection of the current answers? So obviously they give a shit. And if they give a shit, then why are they only happy with simple answers? Because simple answers are rarely satisfying outside of pragmatism. I'm a government shill, and I'm late to get to work. I'm a closeted Irishman. Yeah. I'm not going to claim that, because I'm not going to be like all the other Americans that are like, yeah, I'm Irish. Like, no, you're not. You just want to wear green for some reason and get drunk. have an excuse to wear green for some reason and get drunk. But anyway, I am Professor Parks, and I am an advocate for advancing astronomy. And yeah, I hope you've enjoyed this small snippet of me just rambling on about things and repeating myself from other videos that I've done. So with that being said, I'm going to leave y'all. Peace out and clear skies.